Have you ever wondered how honey is made? This remarkable natural sweetener has been cherished by humans for thousands of years, with ancient cave paintings depicting its harvesting dating back at least 8,000 years. Today, the global industry produces more than 1.8 million tons annually, with China leading production followed by Turkey and Argentina. The fascinating journey from flower to jar involves an intricate process that combines both nature's ingenuity and modern production methods, employing countless workers and sophisticated technology to bring this golden nectar to our tables. The story begins with the remarkable relationship between flowers and bees. Across the world, beekeepers carefully select locations for their apiaries based on the surrounding flora, as different flowers produce distinct honey varieties. Professional beekeepers often transport their hives to various locations throughout the year, following the blooming patterns of different plants. This practice, known as migratory beekeeping, ensures consistent production and helps pollinate countless crops. A single colony can visit up to 500,000 flowers in a single day, and it takes about 2 million flower visits to produce just half a kilogram of this sweet liquid. The selection of apiary locations requires extensive knowledge of local plant species, blooming seasons, and weather patterns to maximize production while maintaining healthy bee colonies. Before any honey production can begin, beekeepers must maintain healthy colonies. This involves regular hive inspections, disease prevention, and ensuring adequate food supplies during winter months. Each hive contains between 20,000 and 80,000 bees, with the queen laying up to 2,000 eggs per day during peak season. The worker bees collect nectar by using their long, tube-shaped tongues called proboscises to suck the sweet liquid from flowers. This nectar is stored in their special honey stomachs, separate from their regular digestive systems, where enzymes begin breaking down complex sugars into simpler ones. Beekeepers must constantly monitor their colonies for signs of disease, parasites, or nutritional deficiencies, implementing preventive measures and treatments when necessary to maintain colony health. Modern beekeeping practices incorporate sophisticated monitoring systems that track hive temperature, humidity, and weight in real time. These technologies help beekeepers identify potential problems early and optimize colony management. Some advanced apiaries even use artificial intelligence algorithms to predict swarming behavior and monitor bee health through video analysis. The implementation of these technologies has significantly improved production efficiency while reducing colony losses. When the bees return to the hive, they pass the partially processed nectar to other worker bees through a process called trophallaxis. These house bees continue to process the nectar by passing it from bee to bee, further breaking down the sugars and removing moisture. They then deposit the processed nectar into honeycomb cells, where they fan their wings to create airflow that helps evaporate excess water. When the moisture content reaches about 18%, the bees cap the cells with wax, signaling that the liquid is ready for harvest. This natural process involves complex chemical changes that transform flower nectar into stable, long-lasting honey. If you're enjoying this video, make sure to subscribe so you don't miss out on our upcoming videos. The harvesting process begins with beekeepers carefully removing the liquid-filled frames from the hives. They use specially designed tools and sometimes smoke to calm the bees during this process. The frames are transported to processing facilities in temperature-controlled vehicles to maintain optimal conditions. Before extraction, the frames undergo a thorough inspection to ensure the liquid is properly ripened and free from any contamination. The waxy caps that seal the honeycomb cells must be removed in a process called uncapping. This is done using heated knives or automated uncapping machines that can process hundreds of frames per hour. Modern facilities employ advanced imaging systems to identify frames that are ready for harvest, ensuring only properly ripened fluid is extracted. The uncapped frames are then placed in an extractor, a large cylindrical machine that uses centrifugal force to spin the liquid out of the combs. Modern extractors can process dozens of frames simultaneously, spinning at carefully controlled speeds to prevent damage to the delicate honeycomb structure. The extracted fluid flows through several filters to remove any wax particles, bee parts, or other debris. Initial filtering uses coarse screens, followed by progressively finer filters that can trap particles as small as 100 microns while preserving the liquid's natural properties. Advanced extraction facilities use computer-controlled systems to optimize spinning speeds and duration based on honey viscosity and temperature. The development of extraction technology continues to evolve, with innovations focusing on maintaining liquid quality while increasing efficiency. Some facilities now use ultrasonic extraction methods that can improve yield, while reducing mechanical stress on the honeycomb. Others have implemented closed-loop systems that minimize exposure to air and potential contamination during the extraction process. These technological advances have significantly increased production capacity while maintaining or improving product quality. After extraction, the liquid enters a settling tank where it remains for several days. During this time, any remaining wax particles or air bubbles naturally rise to the surface, where they can be skimmed off. The temperature in these tanks is carefully controlled, typically maintained between 32 and 40 degrees Celsius, to keep the honey fluid without damaging its natural enzymes and beneficial compounds. Some facilities use cream of tartar or diatomaceous earth to help clarify the liquid further, though many producers prefer to maintain its natural state. Modern settling tanks are equipped with temperature sensors and automated stirring systems to ensure uniform consistency. Quality control in honey production has become increasingly sophisticated, incorporating advanced analytical techniques and automated monitoring systems. Samples are regularly tested for moisture content, which must be below 20% to prevent fermentation. The liquid's color, flavor, and aroma are assessed using standardized grading systems, and it undergoes laboratory analysis to verify its authenticity and ensure it meets food safety standards. Modern facilities use near-infrared spectroscopy and other advanced techniques to detect any adulteration or contamination. Each batch is tested for residual antibiotics, pesticides, and heavy metals to ensure it meets international safety standards. Recent developments in quality control include the use of DNA analysis to verify botanical origin and detect potential adulterants. Mass spectrometry techniques can identify trace compounds that indicate geographical origin, while nuclear magnetic resonance spectroscopy helps verify honey authenticity. These advanced analytical methods have become essential tools in maintaining product integrity and combating fraud in international trade. The packaging process begins with the liquid being warmed slightly to achieve optimal flowing consistency. Modern filling lines can package thousands of jars per hour, using precision equipment to ensure accurate filling weights and prevent drips or spills. The jars are usually made of glass or food-grade plastic and must be thoroughly sterilized before use. Many facilities use automated systems that clean, fill, cap, and label the containers in one continuous process. Special attention is paid to creating an airtight seal that will prevent moisture absorption and maintain the honey's quality during storage. Advanced vision systems inspect each container for proper filling, sealing, and labeling, automatically rejecting any that don't meet specifications. Different markets require different packaging solutions. While retail customers typically purchase honey in small jars, ranging from 150 grams to 1 kilogram, industrial customers might order it in drums holding up to 300 kilograms. Some specialty markets prefer honeycomb sections or cut-comb honey, which requires careful handling to preserve the delicate wax structure. The packaging must also comply with various international regulations regarding labeling, including information about the liquid's origin, botanical source, and nutritional content. Sustainable packaging initiatives have led to the development of recyclable and biodegradable packaging options that maintain product integrity while reducing environmental impact. Storage and distribution of honey require careful attention to temperature and humidity control. While it has an indefinite shelf life due to its natural preservative properties, improper storage conditions can lead to quality deterioration. Warehouses maintain temperatures between 18 and 25 degrees Celsius, with relative humidity below 60%. The product is typically stored on pallets to allow air circulation and prevent moisture absorption from concrete floors. Some varieties of honey may naturally crystallize during storage, a natural process that doesn't affect quality but may require gentle warming before sale. Modern warehouses use automated environmental control systems and real-time monitoring to maintain optimal storage conditions. Transportation of honey occurs through various channels, from local delivery vans to international shipping containers. For export markets, it is often transported in bulk containers that can hold up to 20 tons. These shipments require careful documentation, including certificates of origin, analysis reports, and customs declarations. Temperature-controlled containers are used for long-distance transport to prevent quality degradation. Global trade involves complex logistics networks with major producing countries shipping to markets worldwide through established trade routes. Advanced tracking systems monitor shipment conditions throughout the journey, ensuring product quality is maintained from producer to consumer. The honey industry faces several challenges, including climate change affecting bee populations, disease outbreaks in colonies, and competition from artificial sweeteners. However, demand continues to grow as consumers increasingly seek natural and healthy alternatives to refined sugar. The industry has responded by developing new technologies for hive management, honey processing, and quality control. Some producers are implementing blockchain technology to ensure traceability from hive to consumer, while others are exploring ways to support bee health through improved habitat management and breeding programs. Research into colony collapse disorder and other threats to bee populations has led to innovative solutions for protecting these vital pollinators. Sustainable beekeeping practices are becoming increasingly important as awareness grows about the crucial role of pollinators in global food security. Many producers are adopting organic certification standards, avoiding chemical treatments in hive management, and working to preserve natural forage areas for their bees. The industry also supports research into bee health, breeding programs for disease resistance, and the development of more efficient production methods that maintain honey's natural properties while meeting growing global demand. Conservation efforts include creating bee-friendly landscapes and establishing protected areas for native pollinators. This complex journey from flower to jar involves countless dedicated individuals, from beekeepers tending their hives to quality control specialists ensuring food safety standards are met. The process combines ancient knowledge with modern technology, resulting in a natural product that has remained essentially unchanged for millions of years. As our understanding of bee biology and behavior continues to advance, innovations in honey production emerge, though the fundamental process remains true to nature's original design. The future of honey production lies in balancing traditional methods with technological advancement while ensuring the sustainability of both bee populations and their natural habitats. Different foods contain honey, cakes on porridge, etc. If you enjoyed learning about how honey is made, don't forget to like the video and subscribe to our channel for more fascinating content on food production.